In today's world, most people are familiar with the basic concept of a computer. We hear terms like CPU, RAM, and motherboard all the time. But do we really know what they mean? This guide aims to demystify the main components of a desktop computer. Computers might seem complex, but breaking them down into their individual parts can make them much easier to understand. By the end of this guide, you'll have a clearer picture of the essential components inside your desktop computer and how they contribute to its operation. We'll start by looking at the simpler components: the case, power supply, and motherboard. Then, we'll dive into the more complex components like the CPU, RAM, hard drive, and graphics card, using everyday analogies to make them more relatable. The case, also known as the chassis, is the outer shell of your computer. It holds all the other components together in one place, providing a protective enclosure. Think of it as the body of a car, which houses the engine, seats, and other parts. Without a case, your computer's insides would be exposed and vulnerable to dust, damage, and other environmental factors. Cases come in various sizes, from small form factors to large towers. The size of the case often determines how many components you can fit inside it. Besides providing physical protection, the case also contributes to airflow and cooling. Good cases are designed to facilitate the movement of air, helping to keep components cool and functioning optimally. In summary, the case is the foundation of your computer build. The power supply unit, PSU, is like the heart of your computer. Just as the heart pumps blood to various organs, the PSU delivers electrical power to all the components in your computer. The PSU converts the electricity from your wall outlet into a form that the computer can use, providing the necessary voltage and current to each component. One of the most important aspects of a PSU is its wattage rating. This indicates how much power it can supply to your computer. Higher-end gaming or workstation PCs often require PSUs with higher wattage to support power-hungry components like high-end CPUs and graphics cards. PSUs also come with different efficiency ratings, usually indicated by an 80+ certification. Higher efficiency means less wasted energy and lower electricity bills. It's crucial to choose a reliable PSU, as a failure can cause damage to other components. In essence, the power supply is the lifeline of your computer, providing the necessary energy to keep all components running smoothly. The motherboard is often referred to as the backbone of your computer. It's a large circuit board that connects all the different components, allowing them to communicate with each other. Think of it as a central hub or a nervous system in a living organism. The motherboard contains various slots and connectors for essential components like the CPU, RAM, and storage devices. It also has expansion slots for additional components like graphics cards, sound cards, and network cards. One key feature of the motherboard is the chipset, which determines the compatibility and capabilities of the system. The chipset manages data flow between the processor, memory, and peripheral devices. In addition to connecting components, the motherboard also provides power to various parts of the computer through its power connectors. Ultimately, the motherboard is essential for the overall functionality of your computer, serving as the central platform that ties everything together. The Central Processing Unit, or CPU, is often called the brain of the computer. It's responsible for executing instructions and processing data, making it one of the most critical components. Imagine the CPU as a chef in a kitchen, orchestrating all the cooking tasks, ensuring everything is done efficiently and correctly. CPUs come in various models and speeds, measured in gigahertz or GHz. Modern CPUs have multiple cores, allowing them to perform several tasks simultaneously. For example, a quad-core CPU can handle 4 tasks at once, significantly improving multitasking and overall performance. The performance of a CPU is influenced by its architecture, clock speed, and the number of cores and threads. High-performance CPUs are essential for tasks like gaming, video editing, and 3D rendering, where processing power is crucial. Another important aspect of the CPU is its cache, a small amount of fast memory located on the processor itself. In essence, the CPU is the driving force behind your computer's performance, handling all the calculations and instructions that keep your system running smoothly. Random access memory, or RAM, is like the short-term memory of your computer. It provides a space for the system to store and quickly access data that is actively being used. The more RAM you have, the more tasks your computer can handle simultaneously without slowing down. RAM is measured in gigabytes or GB, and modern computers typically come with anywhere from 4 GB to 64 GB of RAM or more. Basic tasks might need 8 GB, while gaming and video editing benefit from 16 GB or more. RAM is volatile memory storing data temporarily while the computer is on. In summary, RAM is crucial for smooth multitasking and efficient performance. The hard drive is the long-term memory of your computer. It stores your operating system, applications, and files. Think of it as a filing cabinet for your documents. There are two main types: hard disk drives, HDDs, and solid-state drives, SSDs. HDDs use spinning disks to read and write data. SSDs use flash memory, offering faster read and write speeds. SSDs are ideal for the operating system and frequently used applications. Storage capacity is measured in gigabytes, GB, or terabytes, TB. More storage is needed for photos, videos, or games. The hard drive ensures your files are safely stored and accessible. The graphics card, also known as the GPU, graphics processing unit, is responsible for rendering images, videos, and animations on your computer's display. Think of the GPU as an artist, creating the visual elements that you see on the screen. For gamers, video editors, and designers, a powerful graphics card is essential for smooth performance and high-quality visuals. Graphics cards come in various models, with different levels of performance and features. High-end GPUs are capable of rendering complex three-dimensional graphics and supporting high-resolution displays, making them ideal for gaming and professional applications. One key feature of a graphics card is its VRAM, video RAM, which is dedicated memory used to store image data. More VRAM allows the GPU to handle higher resolutions and more detailed textures. In summary, the graphics card is the powerhouse behind your computer's visual output, ensuring that you experience smooth and stunning visuals. Cooling systems are essential for maintaining optimal temperatures inside your computer. Just like how a car needs a radiator to prevent the engine from overheating, your computer needs cooling to keep its components from getting too hot. Overheating can lead to reduced performance and even damage components, so effective cooling is crucial. There are two main types of cooling systems: air cooling and liquid cooling. Air cooling uses fans to move heat away from components, while liquid cooling uses a liquid coolant to absorb and dissipate heat. Both methods have their advantages and are suitable for different types of builds and performance needs. Air cooling is the most common and affordable method, with many cases coming with pre-installed fans. Liquid cooling, on the other hand, provides superior cooling performance and is often used in high-end gaming and overclocking systems. In essence, cooling systems play a vital role in ensuring your computer runs efficiently and reliably, preventing overheating and maintaining performance. Internal wireless cards allow your computer to connect to Wi-Fi networks without the need for external adapters or cables. Think of them as the wireless communication hub of your computer, enabling you to connect to the internet and other devices seamlessly. Wireless cards come in different standards, such as Wi-Fi 5, 802.11ac, and Wi-Fi 6, 802.11ax, offering varying levels of speed and performance. Wi-Fi 6, for example, provides faster speeds and better performance in crowded networks, making it ideal for modern homes and offices with multiple connected devices. Installing an internal wireless card is relatively simple, involving inserting the card into a PCIe slot on the motherboard and connecting the antennas. Some motherboards come with built-in Wi-Fi, eliminating the need for a separate card. In summary, internal wireless cards provide the flexibility and convenience of wireless connectivity, making it easier to connect to networks and devices without the hassle of cables. In conclusion, understanding the main components of a desktop computer can demystify how these powerful machines work. From the protective case and power supply to the complex CPU and graphics card, each part plays a crucial role in the overall functionality and performance of your computer. By breaking down these components and using everyday analogies, we can appreciate the intricate workings of our devices. A basic understanding of these components will help you make informed decisions when upgrading or troubleshooting your computer. Remember, the case houses and protects all the components, the power supply provides the necessary energy, and the motherboard connects everything together. By grasping these basics, you'll be better equipped to appreciate and enjoy the technology that powers your daily life.